This is our follow-up to the practical that we looked at last lesson, where we reacted unsaturated and saturated molecules with bromine water. So here I've got a molecule of cyclohexene, and we're going to show how it reacts with the bromine water. So the cyclohexene, you can see, has got 6 carbons in its chain. You can see where the double bond is located between 2 of the carbon atoms, and you can see that there is no end to the chain, so therefore it's cyclic in nature, hence the term cyclohexene. We're reacting with the diatomic molecule bromine, which is dissolved in a solvent, making it aqueous, and we're going to have a look at how these two react together and in what way. So as we know, in a reaction, bonds have to break, and then once they've broken, new bonds can reform. So one of the single bonds within the double bond of the cyclohexene will break, as well as the bromine water or the bromine single bond between the atoms. So they'll break upon collision. However, we can't actually demonstrate that. So this is a limitation to this particular modeling of the reaction. So once the bonds have broken, we'll actually have new bonds formed. So I'll just show that by moving the bromine atoms across to our carbon chain. So there they are. So now we've got the unpaired electrons have satisfied their octet rule. They have formed a pair of electrons, and this would be demonstrated through a straight line showing a new or 2 new covalent bonds being formed. So there they are there. So the new covalent bonds formed between the carbon, 2 of the carbon atoms in the chain, and the 2 bromine atoms. So we actually call this reaction an addition reaction, because if we look at the definition of addition reactions, they occur when 2 reactants add together to form a single product. There are no leftover atoms. And you can see the structural formula that we have here is also followed up with the condensed molecular formula down the bottom there. So it's C6H10 plus Br2 becomes C6H10Br2. So you can see there's 2 reactants, only 1 single product. When we actually reacted cyclohexane and bromine water, we were able to see that there was no reaction. Why? Because there was no change in the color of the bromine water. So we can't actually show any new products because there weren't any. The bromine water remained as is in its orange color as it was initially, and the cyclohexane remained as well. We'll just skip that part for a moment. Now, what you're going to be asked to look at next lesson are addition reactions involving ethene. And so you can see with ethene, it's got its 2 carbons, they've got a double bond between them, and then the rest of the atoms are hydrogen within the structure. And so you can imagine that the reaction is going to take place within that double bond. So I'm going to get you to watch another video now where you can see smaller molecules like ethene react with other small molecules in order to form 1 single product. That is the key part of addition reactions, that they only form 1 single product. So I hope that helps, and I will see you tomorrow.